In this video, we are going to introduce you to an innovative solution that can revolutionize the way company manage their work environment. The company work environment management system is a cutting-edge software designed to enhance productivity, employee engagement, and overall well-being. Within organization, let's dive into key features. First, this system utilizes advanced facial recognition technology to ensure that right person is sitting in front of the camera. By accurately identifying the individual, it eliminates the risk of unauthorized access and promote a secured work environment. Next, the system tracks key points on the pose such as hands, face to identify specific activities. It can detect action like taking a phone call, looking away from the screen, or working. This is valuable data provide insight to employees' behavior and help organization optimize work process. One of the standout feature of this system is its lightweight nature. It can operate directly in browser, eliminating the need for complex installation or resource-heavy software. This simplicity ensures seamless integration in existing workflows and enhance user accessibility. By selecting the main function option, we will dive into the heart of our application, where prediction and database operation take place. For the second option, we will explore that shortly. As you can see on the screen, we have two distinct sections, face recognition and pose classification. These screens allow us to monitor and analyze specific activities of individual in real time. Down below, we have our powerful database. We'll talk more about that in database section. Now let's move on to the exciting part, the live demo. I'll demonstrate how the system accurately predict and update the database based on my actions. As you can see, the system correctly predicts that I am working on my computer. It reflects the result on the screen. Now, if I take a phone call, the system recognizes the change in my position and update the prediction accordingly. Notice how the system automatically calculates the duration for my previous action and update it with the change to the next post. This ensures accurate tracking of activity durations. Let's do it again. I'm using my phone, and as I switch to a new post, the system updates my previous action and adds the duration to my phone usage for today's date. Now, I'll perform a different action. As soon as I change to the new post, the system updates the previous action and adds 4 seconds to my phone usage. Lastly, when I move away from the screen, the system recognizes the new post and start calculating the duration and frequency of me looking away from the screen. On the top of the screen, you will notice a slider with two options. If you have a good lighting condition and a decent camera, you can use the light model for face recognition. It employs hard cascade to detect faces efficiently. However, if you are in a poorly lit environment, the heavy model is recommended. It runs on multitask CNN and provide a higher accuracy, although it may introduce a slight delay in live result update on the screen, but it works absolutely fine on backend and update the database correctly. Also, you will get a huge jump on accuracy from 80% of hard cascade to over 98% with MTCNN. Now let's explore how we can train a new face in a system. In this section, we can submit a set of images along with a person name. Please note that all fields are mandatory and we cannot leave any of them empty. Before we proceed with the training, let's first test the model prediction on a new face that it hasn't been trained on. This helps us ensure the accuracy of our system. During our demonstration, you might have noticed that if we show a new face to the model, it does not predict or recognize it. This behavior is expected since the model has not been trained on that specific face. It is important to highlight that in a production environment, we can implement additional feature to handle scenarios where the model detects a wrong face or when mobile images are used, which may result in inaccurate attendance records. One approach to address this by incorporating object detection and prediction scoring. This technique can help us determine the likelihood of face being correctly detected and allow us to make informed decision about adding records to database. However, for the purpose of this demo, we have not included these advanced features. Now let's train a new face. Here we can have a set of images of Indian actor. Typically, we only need around 5 well captured images for good classification. We'll provide the person name and initiate the training process. After clicking the train button, we patiently wait for approximately 10 to 15 seconds while the model train on the provided images. The training time is roughly 3 seconds per image. Once the training is complete, our model should be ready to recognize and predict the newly trained face. Let's test it out. As you can see, the system accurately recognized the trained face. It successfully predicting and classifying the face in different images. Now let's explore the reset feature by clicking the reset model button. We'll revert the model back to its default settings. Upon resetting the model, we receive a confirmation message. Now let's see how our system react to previously trained images. As you can observe, the model is no longer predicting the previously trained face correctly. This behavior is expected since we have reset the model to default settings. Now let's train a different face. We will go through the same process by navigating to the train new face section and adding a new class name and initiating the training process. Again, we patiently wait for around 10 seconds while the model trains on a new face. It's essential to note that for the future update, we can only use JPG format images for training the model. With training completed, our model should now be able to recognize a newly trained face. Let's verify this with a prediction. As you can see, the system accurately recognizes a new trained face. It confirms that the model has successfully learned and adapted to a new face. To conclude, Let's reset the model once again to its default setting. Now the model has been resetted and we can observe that it no longer recognizes a previous face. Now let's take a closer look at database functionality of our application. Here you can see the daily database. The system automatically adds a new record for each employee every day. It includes the time of joining and last seen time of the day, along with the activities performed by employee. It's a Cassandra database that runs on NoSQL architecture, providing scalability and flexibility for handling a large amount of data. Each row in the database represents the activity of person for a single day. This structure allows us to track and analyze individual actions over time. One unique aspect of our system is that employees do not need to log in or use any special ID. Simply opening the web page or new tab in a browser allows the app to recognize their face and associate it with their attendance and database entry. Your face is your ID. Additionally, we can also track the total activity of employees throughout their tenure. This data provides valuable insight for monitoring employees' performance and productivity. Let's get back to our landing page. Here you can see my social handles. Allow me to show you my GitHub profile. Here is the GitHub repository for our current project. As you can see, we maintain a professional directory structure and adhere to coding standards. The project follows a modular coding style, making it easy to understand and contribute to. Anyone is free to contribute to the project. In the activity section, I added CI/CD pipeline that perform code linting and checks for bug. It automatically pushed the code to our AWS platform. Now let's go back to the code section. Here you can see that we are using a custom domain for our application. Setting up a custom domain is easy using a DNS service. The link also has a SSL certificate ensuring that the data you submit is encrypted and secure from any middleman attacks. Here, our app is running on AWS EC2 instance. You can also access the app using the IP address shown here. As you can see, the app is functional when accessed via IP address. However, I don't recommend running the application this way as it's lack SSL certificate for secure communication. That concludes our video and tour of our application. The scope of this application is vast as it can be utilized for various tasks such as yoga training, gym workout, dance practices, and much more. We hope you enjoy exploring our application. Keep exploring and discovering its capabilities. Thank you for watching.